We're on page 25 in your packet. And this is about means. Yesterday we did problems on proportions, and today we are going to do problems on the means. Now, I want to do a little review of some notation. As we just talked about in your stopwatch lab, X stands for an individual piece of data. And tell me what X bar stands for. That is the sample mean. Because a Greek letter mu stands for the what? Population mean. Okay, so let's let that sink in for just a second. So you have to, as you read information, pay attention to the sample mean versus population mean and the way that they are notated. Okay. Now, on Tuesday, when you return with all your little X bars, you know everybody gets an X bar. What do you think they're going to be close to, by the way? 5 seconds. Good. Everybody's going to be close to 5 seconds. What do you think probably the population mean is? 5. Yes, very good. Okay. But whenever you all come back with your X bars, I'm going to get the data and then I'm going to plot it on a graph just like we did our P hats. And so we're going to get the mean of the X bars. What is that going to be? The mean of all.
Shouldn't it be the population?
Yeah, it's the mean of all. That implies like population of all what?
Sample.
Good. All the sample means. The mean of all sample means. And let's look over here. Right here. Do you see that?
Yes.
That tells me that the center or the mean of all sample means will be located where? The mean of all the samples should be located at the what? Population mean. Good. So that means when I plot all of your X bars, I expect it to be centered around the population mean, which is 5. Okay, very good. Now, don't we wonder how varied, how much different your X bars, your personal X bars are from each other and how far they are away from what they should be? What's going to tell me how varied they are and how far they are off? This right here. This is your standard deviation of all of the X bars. Okay? Now, do you know how, remember on the previous information we did, we had to do the standard deviation of the P hats, took its own formula? This does as well. Standard deviation of X bars has its own formula as well. And let me explain to you what it is. See these two numbers right here in this first example? These are population numbers. So a regular old sigma is a population what? Standard deviation. And that is different from this. This is the standard deviation of the X bars. So that's what we'll plug in here. They'll give you that sigma. This population standard deviation will be given to you. You will then have to do the formula by dividing it by the square root of your what? Sample size. Very good. Okay, good job. That's it. That's all that's different. Let's practice and see how we do. So here we go. Given that X is normally distributed, so all the individual data is normally distributed, and it has a mean of 30 and a standard deviation of 4, that's the population. A sample size of 64. Find the probability that a sample mean, so in your mind, what symbol are you thinking of for sample mean? X bar is more than 31. Okay, so just like we've done on all the other stuff, we're going to write our list of information over to the side. So our first thing, N is 64. The mean of the X bars, the mean of all the samples, will be centered around the population mean, the true mean. Which on this problem, what is it? 30. Very good. Okay. The standard deviation, so the variability of all of our sample means, has its own formula. And that's standard deviation over the square root of n, which in this case is 4 over square root of 64. And that's 4 over 8, which is 1/2. Okay? All right. And so then, let's see, next, how about just a simple old, what's an X bar that we're going to be dealing with on this? That is the sample mean, and it wants to see if it's more than, so our sample mean is 31. Okay, I am not going to be having you do this problem here, so therefore I'm going to use this space to draw a picture. So I'm going to draw the picture. Where will my picture be centered? At 30. So you know what's going to be in here? Somebody's sample mean. Another person's sample mean. Another person's sample mean. And everybody's going to get all of these different sample means. And which one are we wondering about? Good. We are wondering about this one right here. This X bar that is at 31. And what are we wondering about it? If it is more than that. Good job. So, let's now do what? Z-score it. Okay, so the z-score for our proportion problems were p hat minus the p over the standard deviation of p hats. These are x bars minus the mean over the standard deviation of x bars. X bar minus the mean over the standard deviation of x bars. So fill in your information. That's where your 2 came from, right? Caden, you were just ahead of the game, right?
You said yeah.
And then, remember how to write our answers? The probability of getting an X bar greater than 31 is 2. Oops, I think I messed up in there. It's 2 point, hold on, I don't know. It's 2.28. Why I'm getting different problems mixed up. Sorry. 2.28%. When I do all these different problems, I get those mixed up. Okay. Very good job. Now, I want to see if you can do one of those on your own. So, I want you to do problem number 3 right here on your own. Go for it. .0038. What's that? Did you do that part yet? Oh, okay. Never mind. It's okay. I'll go ahead. I got the answer. Because the z-score for 1.85 is 0 since it is the mean. And it's asking between 2 things. So you have 2 x bars.
Right.
You got to do both z-scores. The z-score for the lower one is 0 because it is the mean. The z-score for the upper one is why I put the 1.9 right here. This is the mean. Okay?
Singing out there.
Yes.
Okay, notice how the notation is for that answer because it's a between. Okay? And so that's all the ones that I need to go over with. I mean, I think that you might have been pretty okay with that, followed along with that. So your assignment, besides doing your stopwatch lab, is to finish the problems, all of the problems, the mean and proportion problems on pages 27 to 32.